Okay, take out your exercise book. Right, let's do this one. This is the homework I gave you. And if you didn't do it, make sure that you do it now along with me. And once you do a homework, you can share it in the group so that I can correct. I can check and correct. So feel free to share what you do there. Then others will also learn, right? And others will also get motivated when you do. Right. So I told you that when we are representing negative numbers, right? Negative numbers. If you have any questions, ask, right? Negative numbers in the computer, we use two methods, right? One method is called sign and magnitude. That's what we did last time, right? Sign and magnitude. The other method is called 2's complement. 2's complement. We did both. Check the last video if you missed it. We did both, sign and magnitude. In sign and magnitude, when we have a binary number like this, the last, the first digit to the left, right? First digit to the left, or the digit or the bit which has the highest positional value, right? Because this starts with 1, 2, 4, 8, 16. So in this particular number, this bit is the bit which has the highest positional value, which is 16, is called the most significant bit. So the bit which has the highest positional value is the most significant bit. Okay. This is reserved to show the sign. What is this sign? It's either plus or minus, right? And how do you show plus or minus in using this most significant bit? If it is plus, we represent it using 0. If it is negative, we represent it using 1. So if this most significant bit is 0, right, it is going to be a positive number. If this is going to be 1, it's a negative number. And the rest of the bits is called, right, the magnitude. Rest of the bits is called the magnitude. This is called the sign. And that's how the name comes. Sign and magnitude. Is that clear? All of you? Yeah? Any question?
Yes, sir.
Okay. Right. Venu, Kanuti, is that clear? Sign and magnitude method?
Yes, sir.
Okay.
Yes, sir.
We'll do some past paper questions on the right. In 2's complement, what we do is we first get the, now there are a few steps in this. The first step is to convert the denary number to binary. And in binary, we have to represent it using 8-bit, 8-bit binary. So if you don't have enough bits, you will have to fill zeros to fit into 8 to make it 8. For example, if your binary number is like this, you know there's only 4. Add zeros to make it 8. 1, 2, 3, 4, 5, 6, 7, 8. And after that only you move to the second step. Okay. So in the exam, don't make that mistake, right? If there's only fewer bits than 8, make sure that you add zeros to make it 8-bit. We are working with 8-bit binary numbers, right? Next step is to flip the bits. Flip the bits. That means 0 will be turned to 1, 1 will be turned to 0. This is also called invert. You invert the bits. Once you invert, what you get as the number is called 1's complement. So when you invert the numbers, invert the bits or flip the bits, the result is 1's complement. Then to make it 2's complement, what you do is you add 1 to the number. Once you add 1 to the number, it's in 2's complement form. Okay, so these are the 3 steps that you have to follow when you're converting it into 2's complement. Right, so I gave this homework. Let's try all 3. I think I did the first one. Okay, let's try all 3, right? Okay, let's take this one. So you're also going to do it with me. Can you take your exercise book and do it with me, along with me? And if you have done it already, just check, right? Okay, so first thing is 113, right? We need to represent 113 in 2's complement. Okay, what do you have to do first? We need to convert 113, right? Just forget about minus. We have to represent 113 in 8-bit binary. And you know how to do it. You just write 1 to all the positional values up to 8 bits. 1, 2, 4, 8, 16, 32, 64, 128. So if you are using 8 bits, we end up in 128. Now you fill 113 into these slots. There's no 128, right? So it's 0. There's 164, right? Right. So now you can minus 64 from 113. That's that is minus 4. 13 minus 4. That's 9, right? This is 6. Four. Yeah, 49. So that's 49 left. We can put 32 there. So 49 minus 32. 17 more. Now you have to fill these 17 into these slots. That's 116. Only 1 left. So you can put that right there. Okay, the rest will be zeros. So this is the easiest method of converting 113 into binary. Otherwise, you will have to go on dividing this by 2, putting the remainder in front. Okay, those who did you get this as the answer? This is correct. If you want to check whether this is correct, just add these up. That's 164, 132, and 116. 64 plus 32 is 96. 96. 96 plus 16. 96 plus 10 is 106. Plus 6 is 112. And there's one more. 112 plus 1 is 113. So this is correct. Understand? Everyone understood how I got this number? Anyone who missed the lessons,
Yes, sir.
can let me know. Oh, okay, great. Anyone who couldn't understand? Definitely there will be questions from this binary chapter. And these are the easiest questions that you can get answers for. Because it's just a small mathematical work that you have to do. If you get the idea, it's really easy. You can score the maximum. Anyone who didn't understand how I got this number? 64 plus 32, 96 plus.
No, sir, understood, sir.
Okay, great. 96 plus 10 is 106, plus 6 is 112, plus this one, 113. Okay, right. That's the first step. Now, what is the second step? Second step is to flip. Right. So how do you flip? Just invert. This is 1 will be turned into 0. 0 will be 1. 0 will be 1. 1. 1 will be 0. 0. 0 and 1. Simple. And the third step is to add 1 to this. Right. You add 1 to this. You know binary addition. Add 1 to this. So 0 plus 1 is going to be 1. Right. There's nothing here. So it's 1, 1, 1, 0, 0, 0, 1. This is the answer. Okay, this is 100 and minus 113 in 2's complement. Okay, now you can see it's completely different from the 130 from the original number. Right, those who did Check whether you got this answer. If not, you complete. I'll give you 1 minute. Just do the same thing. I mean, you do the workout on your own in your exercise book. Okay, finish. Shall we move to the next one?
Okay, sir.
Don't just copy it, right? You have to do it on your own. Otherwise, not you will not learn it. Right. So the next one is minus 56. Should be displayed in 2's complement. Okay, what do you have to do? First, you need to convert step 1, right? 56 should be displayed in 8-bit binary. You also do it. Once you finish, you take a snap and share it in the group. Then it's a confirmation for me that you did it. Right, 56 in 8-bit binary. How do you do it? Again, you write the positional values in 8 bits, right? 1, 2, 4, 8, 16, 32, 64, 128. Now put 56 into this. How do you put 56 into this? There's no 128s, no 64s, 132, right? Now 56 minus 32, 4, 1. Sorry, 24. Right. Now put 24 into the rest. That's 116. 8 more. 1, 8. Gone. 0. So the rest will be zeros. Okay. Now you can check whether this number is correct. 132, 116, 18. 32 plus 16 is 48. Plus 8 is 56. So the number is correct. Okay. Now to step 2. It's so easy, right? Flip. 0 will be 1, 1, 1, 0, 0, 0, 1, 1. And what is this number? It's the 1's complement of minus 56. After flipping, you get 1's complement. Okay. Step 3. Add 1. 1 plus 1 is 2, and you know that 2 is represented as 1, 0. So you keep 0 and take the carry bit to the other side. And 1 plus 1 is 2 again. You keep 0 and take the carry bit to the other side. 1 plus 1 is 2. You keep 0 and take the bit to the other side. 1 plus 0 is 1, 0, 0 here, 1 here, 1 here. And this is minus 56 in 2's complement. Okay, right. You also do it and check your answer. Later, I will show you how to check whether our answer is correct. We are going to have more classes in the coming week. Okay, so be ready. Those who finished, move to the next one. Do the next question, which is minus 90. Have the answer ready. In the exam, you have to show the steps. Okay. Right. Shall we do the next one? This is minus 90, right? Hello, Tusum. Good afternoon.
Hello, sir. Good afternoon.
First class, no?
Yeah, so I wasn't added to the group, so I didn't know what it. So
Okay,
yeah.
okay. Right. You check the videos, previous videos, right?
Okay, sir.
Okay, so this is 90. This is going to be represented as 2's complement. Okay, so the first step is, the first step is to show 8-bit binary of 90. And how do you do it? Assume you can just continue from here. Just do it, just copy this down. And then when you watch the videos, you can Understand, right? So you write the positional values 1, 2, 4, 8, 16, 32, 64, 128. Okay, now let's fill 90 into this. There's no 128. There's 164. 90 minus 64. That's 26. The remainder is 26, right? Yeah. And 26 can be, you can't put it to 32. There's no 32 in this, so it's 0. There's 116. So the remainder is 10. 10 can be put into 8. There's 1 8 in 10. And the remainder is 2. There's no 4s. 1, 2. And there's no 1s. Okay, now let's check whether this number is correct. Just add them up. 64 plus 16 is going to be 64, 74, 80, right? And then plus 8 is 88. 88 plus 2 is 90. So the number is correct. Okay, so likewise in the exam also you double check, right? Okay, second step is to flip the bits. And when you flip, what do you get? Can anyone tell me? The number, the answer you get is called after flipping. What do you call the result that you get after flipping the bits? Which form? What is that form called? Anyone? We are in the process of converting minus 19 into 2's complement, right? After flipping the bits, what is the form that it is in? Anyone? What is it? Tanuti? This number after flipping is in which state? Venu? Silun?
So is it a complement?
One's complement, huh? It's in one's complement. Right. So to convert into one's complement, you just flip the bits, right? So 0 becomes 1, 1 becomes 0, 0 becomes 1, 0, 0, 1, 0, 1. Now that's in one's complement. To make it 2's complement, you add 1 to it. Simple. Add 1 to it. 1 plus 1 is 2. You know 2 is represented as 1, 0. So you put 0 here and take the carry bit to the other side. 1 plus 0 is 1. And there's nothing here, so it's 1, 0, 0, 1, 0, 1. So this is supposed to be the answer when you convert minus 90 into 2's complement. Okay, right. Next, I'm going to show you how to check whether our answer is correct. Now we have got it in 2's complement. We need to check whether this number is correct. Okay, so I'll show that in a minute. You copy this down and check your answer if you did. Okay, finish. Okay, let's look at whether these answers are correct, right? Let's check. Let's check the answer, the first one. I'm in this page. I'm in page. You turn to this page in your book. 119. I'm in page 119 in the book. Okay, so the first answer was for 113. The answer was 1000 1111. Do you have 8 bits here? 1 2 3 4 5 6 7 8. Okay, now watch closely. Yeah? This is how you check whether this answer is correct. Okay, right, now you have the most significant bit. Now first of all, let's write the positional values of these. Right, this is checking 2's complement answer. Okay, let's write the positional values, right? I think it's better if you also do it. So just write the number first and then do it along with me. So first write the positional value. So this is 1 2 4 8 16 32 64 128. Okay, right, make sure that you also do it. Sulun, okay?
Yes, sir.
Okay, great. Now what you do is you take the most significant bit. Okay, most significant bit, which is this bit, which has the positional value of 128, and you take 128, that positional value, and represent it as a negative value. Okay, the most positional bits, most significant bits positional value is represented as a minus value, and the rest of the bits, or what you can call it as magnitude, right? The rest of the bits, the total of rest of the bits, positional values are taken as a positive value, right? The positional values, the addition of positional values of the rest of the bits is taken as a positive value. Right, now let's add up 8 plus 4. There's 1 8, there's 1 4, 1 2, and 1 1. So 8 plus 4, right? This will be 8 plus 4. Okay, plus 2 plus 1, and that is 12 14 15, right? Plus 15. Now what you do is you add the minus value or the negative value and the positive value together, right? So that is minus 128 plus 15, and the answer is, this will be deducted, right? 8 minus 5 is 3, 2 minus 1 is 1, and 1 minus 113. So our answer is correct. Did you understand? Okay, one more time. What we do is we first write the answer. That's the 2's complement value, right? That's the 2's complement of minus 113. What's the purpose of this? We are going to check whether our answer is correct. Take the most significant bit, write it as a negative value. The positional value as a negative value, which is minus 128. The rest of the bits, which is like the magnitude, represent as a positive value. Just add them up, right? So 1 8, 1 4, 1 2, and 1 1. Altogether, you have 15. So represent it as a positive value. So we have minus 128 plus 15. Add them together, you get minus 113. Is that clear? Any doubt, any question?
Yes, sir.
Anuti, is that clear? Understood? Venu? Silun?
Clear, sir.
Yes, sir.
Yeah, Zoom, it might be hard for you now. It's okay, just follow the videos. And don't forget to
Can you add me
subscribe.
to the group?
Huh?
Can you add me to the group, please?
Which group?
WhatsApp group.
I have added you.
You haven't added me. So you might have added my personal phone number, but then like
I
my
just
personal
added
phone
you.
is like not available
What was
with
that?
me. Like, my personal phone is not available with me right now, so like it's not been available with me for like 1 month. So like
Someone
you,
sent your number to be added now. So I just added a number ending with 557. I added that number. That's not yours.
So I think he's saying that he doesn't have his phone right now.
Ah, right. Okay. You might have added my personal
so like
number.
I gave it to sir. It's kind of like because it broke.
Okay.
Like my personal phone. So I had to use my mother's phone. So like, can you add my mother's number?
No,
Otherwise, I can't. That's why, sir.
they cut my power. Hold on. Right. So the next question is activity 4, question 2 actually, sorry. Activity 4, question 2. And it says, showing your working, carry out the binary addition of 90 plus minus 33. So how do you do something like this? Well, this can be easily done using, now normally how do you do this? You take 90 and you minus 33 because plus into minus is also minus. So 90 minus 33. But here what we do is, yeah,
it should be 57, right?
the answer. Yeah, that's right. But we are going to perform this using binary. Okay, using a binary addition. So normally what we do is we minus 33 from 90, right? But here you can see we have added the minus value to the positive value. We have added. So in binary, we can do this easily using 2's complement. Because we can represent minus values using 2's complement. Okay, so if we can convert this 33, okay, or minus 33, if we can represent minus 33 in 2's complement, we can simply add that value to the binary equivalent of 90. That's how they want you to do it, right? So the first thing is to convert 90 into binary, 8-bit binary, and then minus 33 represented in 2's complement form, and then you add them up. Simple. Okay, so let's do it. Let's do it together. So first, let's represent 90 in binary, right? So again, I'm going to write the positional values 1, 2, 4, 8, 16, 32, 64, 128. Why 128? Because we are dealing with 8-bit binary. Okay, now 90, right? So there's no 128. There's 164. 90 minus 64. 26, right? So 26, there's no 32 in 26. There's 116. And the balance is 10. In 10, there's 1, 8. Balance is 2. There's no 4s. There's 1, 2. And there's no zeros. So this is 90 in binary. And it is positive 90, right? So we don't have to convert this into 2's complement because it's positive 90. For this positive 90, we are going to add the 2's complement of minus 33. So 33, of course, minus 33, of course, you will have to represent in 2's complement. And for that only, we have to add this. Okay. Now let's convert 33 right? Forget about the minus. Let's convert 33 into 8-bit binary. There's no 128, no 64s, 132 is there, right? And you know the balance is 1, so that's going to be right here, and the rest of the bits will be zeros. Okay, right? But that is not 2's complement, right? This is just 33 in binary. So next step is to convert this into 1's complement, right? So this is 8-bit, right? All right, let me show it in steps. First step is 8-bit. That's this one. Second step is 1's complement. So in 1's complement, what do? You invert the bits. So 1 will be 0, 0 will be 1, 1, 1, 1, 0, 1. Third step is to add 1. Then only you get 2's complement. Right, 0 plus 1 is 1. Here it's 1, 1, 1, 1, 0, 1. So this is the 2's complement of minus 33. Okay, is that clear? Right, now we have got plus 90 in binary. We have got minus 33 in 8-bit binary. What do you have to do next? We have to add these two numbers. Okay, remember adding, right? Because you can see here 90 will be added to minus 33, which is same as deducting 33 from 90. So this is 90, 0, 1, 0, 1, 1, 0, 1, 0. This is plus 90. And this is minus 33 in 2's complement. That is 1, 0, 1, 1, 1, 1, 2, 3, 4, 5, 6, 7. Oh, I missed this one. No? There should be 0. Sorry, it should be 1, right? You are flipping now. It should be 1. So 0 plus 1 is 1, 1, 1, 1, 1, 0, 1, and there should be 1. Né? There should be another 1. Okay, so the answer here is 1, 1. Align it nicely, otherwise you will get mixed up. 1, 1, 0, and 5 ones. 1, 2, 3, 4, 5. Okay, let's add them. What we have to do is add, not minus, right? Add. Zero plus 1 is 1. 1 plus 1 is 2. 2 represent using 1, 0. So you keep 0 and take 1 to the other side. 1 plus 1 is 2. Again, you keep 0, take 1 to the other side. This time, 1 plus 1 plus 1 is 3. 3 is represented as 1, 1. So you keep 1 there and take 1 to the other side. Again, you have 3. So you keep 1, take 1 to the other side. 1 plus 0 is 1. 1 plus 1 is 2. You keep 0 and take 1 to the other side. And 1 plus 1 is 2. You keep 0 and take 1 to the other side. Now you can see there's a extra bit which is called overflow. There's an overflow. We talked about overflow in an earlier session. Okay, now we have, okay, I'll give you a little time. You also do it? Okay, finished. I will share the screenshots. You make sure that you also do it, right? Any problem, Venu?
No, sir.
Right. So make sure that you do it again and again. Right. Now we have got the answer. Right. This is supposed to be our answer, but you can see that's an overflow. Right. So what we do is we disregard this overflow bit. Right. And we look at only the 8 bits, right? 0, 0, 1, 1, 1, 0, 0, 1. So this is supposed to be our answer of this addition, right? That's plus 90 plus minus 33. 90 plus minus 33. Okay, now if you just look at this value and see what it represents. If you write the positional value here, 1, 2, 4, 8, 16, 32. And if you add them up, you will see it comes to 32 plus 16 is 48, plus 8 is 56, plus 1 is 57. So this is representing 57. And if you look at the sign, right, the last bit, the most significant bit, even the sign is 0. And 0 means, you know, it's a positive value. If you look at the sign, it's 0, which means this is a positive value. Okay, so we have got our answer, which is 57. If you minus 33 from 90, the answer will be plus 57. Okay, is that clear? Is that clear, everyone? Do you want me to explain anything? Tanuti, Tisum, Venu, Silun? All good?
Yes, sir.
Okay, great. Right, so guys, I think our time is over. And if I try to explain the next section, it will take a long time, right? So what we have next is these shifts, logical shifts and arithmetic shift. These two are a bit difficult. Okay, so that's why I will take it in the next class, right? But have a go through, right? Just try to understand, because they have explained it in binary numbers, right? This is so easy. Only thing is when you do it in binary, it is slightly confusing, right? So this is basically like what shift is. Basically, you are moving the bits. You are moving the bits to the left or the right. Right? I will just take one example and finish it off to tell you what exactly this is going to be. Let me share this first. Okay, so I will take a binary number and explain it quickly. It's something like this. Okay, let's say we have a number like 0, 0, 50. Okay, this is 50, binary 50. I just wrote double zeros for a reason. I'll show you. Okay, now it's 50. Always we'll write 5. I'm going to put a dot and a decimal point as well. Right. Now you know that these are ones, these are tens, because it's in binary. Sorry, denary. What am I talking about? It is in denary. So this is ones, this is tens, and these are hundreds, and these are thousands. Right. When you go to the right side from the decimal point, this will be 1 over 10. Right. This will be 1 over 100. Okay, 1/10 and 100. Understand? That you know, right? Is that clear? This is how the denary numbers work. Their positional values work. Here we are representing 5. Why? Because there's 5 ones. Okay, so the positional values, this is 1, 10, 100. Sorry, this should be 1000. And when you go to the right side from the decimal point, this is 1 over 10 and this is 1 over 100. Is that clear? Yeah?
Yes, sir.
Okay.
Yes, sir.
Now, if I want to multiply this number by 10, right? I want to multiply this by 10, right? Without doing a normal multiplication, what I can do is I can play around with the position of this digit, right? You see that if I move this 5 to the left 1 digit, 5 is going to be right here, right? And the value, right? And the empty space, when you move 5, the empty space, if you fill it with a 0, you get 50, right? I just moved this 5 1 place to the left, and what happened? The previous value got multiplied by 5. So this is what is known as shift. Right now you see, shifting to the left multiplies the value. Simple, right? This is the whole idea, right? But we are going to do it in binary. That's the tricky part. Okay, if I want to multiply it again by 10, what I do is I shift that 5 1 place to the left again. So now the 5 is here. These two will be zeros, right? What happened? It became 500. Okay, right. Now overall, what did I do? I shifted the original number, right? Original number was shifted how many places? How many places? Original number was shifted how many places? 2 places. To which side? 2 places to left or right? To the left. The original number was shifted 2 places to the left. Right. Now this is in base 10, right? We are talking about base 10, denary. I shifted 2 places to the left. So if I write that 2 places as a power value, it is 10 to the power 2. What is 10 to the power 2? What is 10 to the power 2?
100.
100. 10 to the power 2 is 100. Okay. So what happened to the original value? Right? Original value, which was 5, was multiplied by 100. And the result is 500. Okay. So that gives us a kind of a pattern, right? Right. The number of places that I shift is equal to the number that the original value is going to be multiplied or divided. If I move the digit to the left, it's always going to be a multiplication. But the multiplication value, what is this? What is this? Okay. The number that I'm going to multiply is dependent on the number of places that I shift. So remember, if I shift to the left, it's going to be a multiplication. The number of digits that I'll shift is going to be the multiplier of the original number. So I shifted 2 places to the left. So that is 2. If you write it as a power of the base 10 to the power 2, so the original value is going to be multiplied by 100, right? Which means 5 is going to be multiplied by 100 and the result is 500. If I did it step by step, 1 digit to the left, original value is going to be multiplied by 10. Do it one more time, the previous value is going to be multiplied by 10. That means if you do step by step, place by place, it's going to be, the previous value is going to be multiplied by 10, 10 by 10. If you shifted the number of places at once, then the number of places that you shifted, right, is going to be the multiplier. So how do you get the multiplier? You represent it as a power value of the base, right? Is that clear? Okay, now answer this question. I am moving it to the left, 3 places to the left. What will happen to the original value? This 5, I am going to shift it 3 places to the left straight away. What will happen to the original value? Come on, it's really easy. I'm going to shift the original value 3 places to the left. What will happen to it? First of all, think, is it a division or a multiplication? Is it a division or a multiplication? Silun, Kanuti, Tisum, Venu? Hurry up. I'm going to shift this 5 to the left side. Is it a multiplication or a division?
So a multiplication.
It's a multiplication. Okay, I'm going to move it 3 places to the left. So what will happen to the original value? I'm moving it 3 places to the left. So now the original value is going to be multiplied by what? Yo, this is so easy, no? Original value is going to be multiplied by 10 to the power 3. What is this 3 power value? This is the number of shifts. Number of shifts. Understood? Others? Okay. If you are moving the original value to the left 3 places, right, you can write it like 10 to the power 3. Power value is the number of shifts. So what will happen to the original value? Is going to be multiplied by what? Resume. It's going to be multiplied by Venu. It's going to be multiplied by
So 1,000.
1,000. You, why others are thinking? Others, did you understand? It's going to be multiplied by 1,000. Understood, others? Venu, Tisum, Silun.
Yes, sir.
Right. So if you move it 4 places to the left, it's going to be a multiplication, and the original value is going to be multiplied by 10 to the power 4, which is 10,000. Right? Why 4? Because that's the number of shifts that you do. Simple. Okay. If this is the left shift, okay. If this is the left shift, and if left shift results in multiplication, what will happen to the right shift? It's going to be division. Simple. And division will be the opposite of this. Okay, so there's no time to explain the division, but just understand what we are going to do in shifts. And we are going to have two shifts. One is called logical shift. The other one is called arithmetic shift. Okay, we'll see what it is. But logical shift, this is actually logical shift. On binary, on denary is something like this. It's pretty easy. When you move the digit either to the left or the right, you can multiply the previous number or divide the previous number, right? If you do it step by step, it will be multiplied or divided by 10 in each step. If you straight away shift to a certain number of places, the original value will be either multiplied or divided by 10 to the power the number of shifts. Okay, clear? Right, so there we'll stop. I'm going to have some regular classes, right? Because we have only 1 week more. So make sure that you are available. I might not be able to pre-plan the time, right? So I'll have to give you a very short notice, but make sure that you are available. If not, go through the videos, right? Okay, then. See you. Have a nice day.
Sir, will you upload some possible?
Yeah, I'm uploading. Okay.
Okay, sir.
Okay, see you. Have a nice day. Bye.
Thank you, sir. Bye.